multiple linear regression only accept numerical values. So we use num column to identify which column is numeric by using its numeric function and apply to each columns. And we use num data to store the data of numerical columns. And we drop the first column since it is the custom ID columns. And we use code names to show which column is selected as the numerical columns. So these are columns and total span will be our target variables. So we proceed to nominality analysis and we use Shapiro test to perform it. And we use apply, put in our data. Number 2 we represent as apply to each columns and Shapiro test. And we show the result. And we can see that the p-value of them is very small, which means that they reject the null hypothesis, which means this variable is not normally distributed. And the W means that if the W is closer to 1, it shows that they are normally distributed, but since their p-value is so small, so they still not normally distributed. And next we proceed to the correlation analysis by using core function, the Pearson correlation, and using heat map to visualize it by putting the core matrix, display the correlation result number, the colors, and the titles. We can see the map. The total spending have a high positive correlation with item purchase and average rating, and have negative correlation with age and days since last purchase. I also mentioned that the item purchase have a high positive correlation with average rating, so I decided to remove the average rating. And as you can see, the item purchase has a higher correlation with total spending lah. And next we proceed to developing the model. So we use LM function and define the target variables first, and the following are the independent variables. And we use summary model to show the result. As you can see, there are many results, and the intercept in the model is meaningless, since if age, item purchase, and days since last purchase are 0, it wouldn't be this amount of total spending in real life. And this value is the slope of these variables, which means that if age is increased by 1, the total spending will deduct 4.4. If an item purchase is additionally added by 1, and the total spending will add 75. And if an additional day is added since last purchase, then the total spend will deduct 4.5. And so on. And this is the p-value of them, which is quite small, but since the Shapiro test showed that they are not normally distributed, so the p-value result might not be so accuracy to showing them have the effect of total spending lah. And the multiple R-square means that this model has explained 96% of total spending by using these variables.